Hello, my name is Brenda Suggett, and I am the Executive Director of the Canadian Association of Road Safety Professionals, or CARSP for short. I'd like to welcome you to today's webinar, which is entitled, Which Technologies Will Make My Driving Safer, by Dr. Martin Lavallière. First, a little bit about CARSP. CARSP is a national organization dedicated to supporting road safety professionals in Canada and abroad. We're made up of about 500 members from all different disciplines. This webinar, I should make you aware that it is being offered in both languages. First of all, right now, it's being offered in English, and then at 1 o'clock, it's offered in French. If by chance you may have signed up for the wrong one and would like to sign up for the French one and haven't, please put your email into the chat area and we will register for that one. They are two different registration processes and also two separate Zoom links. So we won't be going from one into the next. You do need to sign up for the French one. So once again, just put your email into the chat area and my assistant will sign you up for the French one. Webinars are a regular thing for CARSP. We actually offer free monthly webinars to our members. However, on occasion, we do provide webinars to the public, such as today. If you'd like to be part of CARSP, the membership fee is very affordable. It's $125 a year. So I invite you to check that out. First of all, before I introduce our speaker, I'd like to go over some housekeeping items. First of all, the webinar itself will just be going until 12:55 because we do need time to switch over to the other webinar, which starts promptly at 1 o'clock. There is a question period. It is at the end of the webinar hour, and we ask that you submit your questions using the Q&A function at the bottom of your screen. You can submit them at any time during the webinar, but we will be answering them only at the end. I also want to make you aware that we have a post-webinar survey. This is the first time we've done this, and we have 3 ways that you can access it. We will be putting a link to it in the chat area. Also, once the webinar finishes, a screen will pop up, which will give you access to it. But if neither of those work for you, if you have to leave early, we will also be emailing it to the registrants. Now, without further ado, I'd like to introduce our speaker today. So Dr. Martin Lavallière is a professor of kinesiology at the Department of Health Sciences at Université de Québec à Chicoutimi since August 2016. And thank you so much, Martin, for joining us, and we look forward to your webinar. Thank you.
Thank you so much, Brenda. Good afternoon or good lunch, I should say to everyone. It is really a pleasure for me to talk about technologies that will make my driving safer. Was that a statement? Was that a questions for you? I hope I'll be, in part, be able to answer those questions for you during that hour presentation. It is important to note here that this presentation was led by a collaboration between CARSP, UQAC, but also the Ministry of Transportation of Quebec through their road safety funds that I'll present you a little later during my talk. So why do we talk about technologies? Will it make my driving safer? It's actually a question that in regards, we should look at it at our road to safety overall. Why do I mean by our road to safety? You can see that in the rightmost side of my presentation, there's that black star represented by the collision. And all these circles that are on the leftmost side of the screen are actually the places where we can intervene either as driver, either as road safety professional, either as engineer or designers of vehicle to prevent those collision or the severity of those collision. We can focus here on the rightmost side of the screen with that red dot, which is the reduction of the impact, like airbags, the construction of the vehicle per se, or the environment in which I could collide. But the aim of my presentation today will be solely focused on active driving safety system, which are système de sécurité active in French. We'll also see that they have a lot of names, synonyms, and other spellings for those technologies, and that it might brought confusion among consumers. But more importantly, what we're going to look at, and an example that you might have heard here is autonomous braking or forward collision mitigation, crash mitigation, and system like these. And these are the main topics of interest for us today. First and foremost, and before we shoot at the presentation overall of those technologies and the website that CARSP have developed for you in order to better understand how these technologies will make your driving safer if you drive with them correctly, is the questions of how do people understand those technologies, also how they are sold to consumers, and how they're actually used. Once I buy a car that might have or not those types of technologies, either that they're passive or sometimes active technologies, how are they sold and how do I understand them? Interesting works led at MIT Age Lab, led by Abraham and al. In 2017, has showed us that sometimes the automotive dealership, when they're selling and they're presenting those technologies, often tend to forget to prevent the cons of those technologies and the limitations of those technologies. There's even instance where people would buy those cars and they were not even told that that technology already exists in their car, either blind spot information system or forward collision warning. And we'll see the details of those technologies later on in the presentation. But more importantly is that there's clearly a gap between what my car can do and how it's sold to me as a consumer. The second questions we have to ask ourselves is the questions of the consumer interest in those automation. Another report led by Abraham et al. And other more recent papers have been out there that have shown that more than often, people look for cars, but they actually look for a car that doesn't necessarily have those add-ons features in them or those active safety systems. They're just part of a built-in that is already embedded in the vehicle, and they're just considered as add-on value when they purchase a vehicle or a car, but that their main and sole decision is not solely based on these technologies that are embedded in the vehicle they just bought, or that they're looking for to replace their either older car or that they just want to have a new car. And more importantly, and those were work led by Bobby Sippel in 2019, is that there's a lot of consumer confusion in regards of what is my car doing? What am I expecting in terms of automation? And what do I perceive as what is automated in my vehicle? What is the technology is going to do for me or not? And how there could be misleading information, both in terms of the car dealership, but also the consumers who's going to buy one car and might expect that the technology is going to do something for them, which might never happen in the long run. Here, the from 0 to 5 is that easy to understand, is that when we talk about confusion a little earlier, is that we went from zero automation. Those are the old vehicles you might have learned to drive on. And that's part of that continuum that makes it really complex. If you look at the rightmost side of the screen, you see that we're now in full automation when we reach level 5, as suggested by the Society of Automotive Engineer, SAE, is that there's a wide spectrum of technologies and how each technologies and their eventual combination might lead to different level of automation, but more importantly, it's also level of complexity that are added on the way I might interact or not with a vehicle. I think that the best and fullest description of what could be considered as a full automation vehicle would be more in regards of, it's like if you would sit in a cab, in the bus, or someone who would drive you somewhere. You sit in the car and you're just solely not responsible at all for driving the vehicle per se. So that could even be a car that has no steering wheel or gas or brake pedal, because you're not going to do any part of the driving. This is the 5th level of automation. This one is easy. No automation at all. It's pretty easy as well to understand. But what we want to grasp the knowledge and better show people the differences in that spectrum of technologies is from that level 1 to that level 4 of automation. To give you a better sense is that right now on the market, there's some level 1 that are available, some level 2, which is partial automation, mostly associated with automatic cruise control and lane keeping assistance when they're combined, and I'll show you later why. And we're slowly showing and seeing conditional automation that are making part of the road. Tesla could be a good example. BMW and Mercedes-Benz have also launched some more recent model, but the level 3 is pretty scarce across the car market and is slowly making its way through. So we clearly see that there's a wide distribution of the level of technologies that are available, but also, and more importantly, the level of automation that I can have access to. And one of the reasons behind the scientific watch I'm going to present you a little later on is, but what does drive all those questions and those confusion in regards of advanced driving safety system? And this slide here is a good example. You have in blue example of publication that were done in regards of those technologies in the past few years, when there's one single advanced vehicle technologies that is presented in a publication. We also have combination of those technologies that are presented in vehicle, and that gives you a spectrum. And we can clearly see, because that publication was done in 2020, but it dates back from papers that were scientifically published before 2017, is that we clearly see that there's a wide increase of the number of papers that shows good or bad results in regards of those technologies. But more importantly, that there's a wide spectrum of combination of those systems, and it's wide and a lot of information for people to grasp and really understand how technologies might or might not work in the market. Here are some examples in the upper left of different names and branding of those technologies, and we'll cover them, and we'll cover some of them during my presentation. We have blind spot information system, forward collision warning, forward collision mitigation, that even though they look alike, they're totally different. We also have lane departure warning and mitigation, and I'll go through all of them a little later on. That confusion was already brought up by AAA back in the US in January 2019, where they've shown that there was more than 200 names to identify these types of technologies, and that on average, the panel that I'm showing you on the upper left is that for each of those technologies that we're presenting to you today, there could exist of up or even more than 20 names per types of technologies. So one car manufacturer could be presenting a blind spot information system with one name, and the other car manufacturer could present the exact quote unquote technologies with a completely different name and a different label in terms of information. And that's one of the reasons why there might be so much confusion behind all those technologies, is that they're spread apart not only on how they're going to work and when or not they're going to work, but they're also spread apart just in terms of name that companies are using, trying to establish themselves as leader in that field, but it also leads to confusion for the consumers on the other side. Just to give you a good example of why is there so much confusion behind all these, is that on the upper left of my graph here that figures, you can see the car manufacturer as an example: Mercedes-Benz, Tesla, Cadillac, Audi. We also have the ACC, which is automatic cruise control. The LCA is for lane keeping assistance system. There's also automation and mirrors ends alert if someone is not holding their steering wheel while they're using some of these technologies. And there's some other symbols or signals that the car will produce. One clear thing that we can appreciate from that slide is that we can clearly see that all cars are not made the same. And if I do own maybe two different brands of vehicle, I might face for the same technologies, two different types of interface, two different types of signals and alarm, but also two different types of information that I'm gonna face when I'm driving. And it does create challenge and confusion for consumers, even though we're educated and we've read about those technologies, and we might have not, or we might have had to use in the past those technologies. That's what creates that huge spectrum that requires clear education for people. We've also seen that there's a part of what has to be done in terms of education for road safety in regards of those advanced driving system that is related to the hype that surrounds the misconception about autonomous vehicle. It's a paper that was done back in China, but what's interesting here is that it clearly shows that how cars are branded and how we present the results surrounding those autonomous vehicle, or their different levels of automation in the media, but also on their soul, is that it might lead or not to misconception or even fear of using those technologies, or mistrust in those technologies for the consumers at the bottom end of that pyramid of usage. So the bottom user at the end will have those technologies in their cars, but will they trust them? And will they understand when they work and when they don't work? It's important to note here that the scientific watch we're going to present you today, and it is as part of the new website that was just launched by CARSP, is this project took kind of milestone with a project that I've led when I was in postdoc at MIT Lab with my supervisor there, Bruce Miller, Brian Rimmer, and Joseph Coughlin. And this was a report that we produced for the AAA back in 2014. And as of why is it took so long is that, just to give you and put you in perspective, is that those autonomous vehicles back in 2013 were announced to be fully launched in 2020. Unfortunately, 2020 is already 3 years ago, and now the projection of those automation or fully deployment of automated vehicle are now more projected towards 2030 or even 2035, depending on who we ask, which technologies and which car manufacturer we're asking to. So this is the basic, the foundation of that work. And we've updated these versions because this was all done manually. And that's where we aimed to improve the work that was done initially with great colleagues back then, but with that new collaboration, sorry, with CARSP. What's interesting here is that we did started a scientific watch on active and passive safety technologies for road safety professional. What do we mean by active and passive? I'll explain to you a little later on when I'm presenting specific technologies. But first and foremost, I would like to thank Ministère du Transport et de la Mobilité durable through their programme d'aide financière du Fonds de la Sécurité routière from the Quebec government for funding this opportunity that was done in collaboration with CARSP, as Brenda mentioned in the introduction, but also with the program of Transport Canada Enhanced Road Safety Transfer Payment Program. We also got support because my own salary is paid by Université du Québec at Chicoutimi for all the time that was spent developing that program, or even the time I'm giving today for the presentation we're doing. But we would also like to thank MyTax Global Inc., who funded Mauricio Mercado y Mitola, who was an international Colombian student who spent a full summer with us working at the implementation, the design, and the documentation of the website I'm glad to present you today. But why should we build a presentation and another website on cars? That website on cars goes along and is reached back at the top here for the education system of the 6 E's that we consider for road safety. There's enforcement, there's evaluation, there's engineering, there's equity, there's empowerment, but there's also education. And by providing that scientific watch to people, because that portion of the website will be free of charge for anyone who want to access the information on CARSP website as a general education to public, but also road safety professional, is that we do want to educate people on how these technologies works, what are their benefits, what are their limitations, and when they don't work. We also want to provide them some empowerment because we want to provide them the newest information out there that comes out from scientific publication through recognized website that publish those papers. It's really a knowledge hub for all. So you have here an example of how the website is going to look like, and I'm going to show you different example of how it's layered. It's a scientific watch project. The reason why it's a scientific watch is that we didn't want it to go for fixed and framed in time presentation of results. This is going to be an evolving website along the way. We're also going to add, and I'm going to present them later on the presentation, new technologies along, because when we're going to have enough information to present the benefits of those upcoming technologies, they're going to be added in the list I'm going to present you. More importantly, it's also a bilingual website. So as Brenda mentioned at the start of the presentation, we're presenting the website and the technologies today at 12, but we're also going to make the exact same presentation, but this time in French at 1 o'clock this afternoon, because we really thought that it was important to spread that knowledge and to disseminate that information in regards of road safety, but that it should be from coast to coast and also bilingual for every Canadian. As I've said, it's going to be an evolving website. So we're going to add on new features. They're also going to be add on for new technologies, but also, and more importantly, from the feedback we receive from CARSP users and CARSP members and people from the general public, we are in end and able to modify and bonify the website along the way. So these are technologies that will be presented in the leftmost side of the screen. Technologies presented. For all the technologies presented in this section, some names are common, and in the car industries are trademarks for car manufacturers. So we decided to go for those 7 different names of technologies. But as I've said, these names are big families overall. Big families of names, big families of presentation. But for each and single technologies that are going to be available on the website, there's also namings of technologies and common names that are used in the industry to present people. So they might see automatic cruise control, but their car manufacturer might present it differently. So they'll have that name presented on the website. There's also a section that says, how does it work? So is the system based on camera? Is it based on LiDAR? Is it based on radar? Sometimes it's combination of those systems, but we're presenting to people, I do have these technologies in my car, but it's also important for people to know, how is it running? How is it working? Because it's also part of when it's going to be working and when it might not be working overall for them. There's also a big segment on pros and cons in regards of the use of those technologies, because when we've talked about the usage of those technologies among consumers, we've also seen that sometimes with the integration of those technologies in our vehicle, there's also cons that appears because people might thought or might feel that they're more safely driving because they have the presence of these technologies in their car, and they might compensate that increased level of safety by adopting a higher or more dangerous level of risk while driving. So these are parts of the information that we're providing to people. And last but not least, and that's what makes that website so interesting for people, is that it's going to be automatically updated for a literature search. So not only we do present some important piece of scientific and regulation documentation directly on the website, we're also going to have for each of those 7 technologies that I'm going to present you shortly, we're going to have updated literature review so that people can have access daily or weekly, depending on how they visit the website. Is going to be made automatically anyway. And we do made up a search that will automatically be updated for every technologies. So as for the technologies presented, the first one is automatic cruise control. And you'll see they're all laid out in alphabetical order for the English side of the website, but we've kept the exact same structure and the name labeling for a French presentation. So automatic cruise control is presented. Here we do present the automated or automatic cruise control in terms of, we did add cruise control in the past where you would set up your speed, but now automatic cruise control is also compensating for the distance with the car that is ahead of you. So the car and the technologies embedded in it, either using LiDAR or radar, is also compensating for the times to contact with the vehicle in front of the driver, but also adjusting depending on the level of comfort of the driver. Some technology does enable the driver to adjust the distance at which they feel comfortable following the car in front of them. We've seen great benefits from those automatic cruise control systems, but more importantly, those automatic cruise control systems are shown beneficial to adjust for speed and adjustment in terms of cognitive control for the driver, but they're also and more efficient when they're combined with some forward collision warning or mitigation systems that I'll present a little later. We also have backup cameras and sensors. You might be a little more familiar with these ones because we've seen a lot of backup camera systems embedded in car recently. Since 2018, these backup cameras are now mandatory in every new built vehicle in the United States, and therefore Atmos kind of automatically introduced in all the vehicle produced for the Canadian market. There's sometimes combination for backup cameras. Depending on those technologies, it varies in terms of field of view. What is presenting? Sometimes we have bird's eye view, so we also have cameras that surround the full 360 degrees surrounding the vehicle. And there's also backup sensors, which will beep when someone's getting closer. And the backup cameras are also adapted with some user interface that will change. Sometime when you turn the steering wheel, it will provide you a line where you're going and when you're not going. And where you're not going, sorry, but it's part of the information that are of interest. Here, more importantly, the backup camera system is one of the one that shows really good potentials of benefits in terms of papers because there's a high risk of collisions with pedestrian, and more than often, those are children that sits or that are playing around the cars sometime when we back up in our driveway. And they're there. However, there's sometimes some misconception that we've also seen when using those backup cameras that people will only allocate their driver, their attention and their cognition towards the cameras while forgetting to watch for the surrounding environment. And that might be the reason why we haven't seen so much benefits for backup cameras and sensors, because people tend to forget the environment surrounding them. One of the other technologies is adaptive headlight. Adaptive headlight will be adjusted. Sometimes it's called steering headlights, is that the car will steer the direction of the beam of the headlights in the car depending of the curves or sometimes slopes that the car will be facing in. These are made to adjust the lighting of the vehicle in the direction and of the car path, and it does adjust these to better emphasis the environment where I'm driving, especially at night or when visibility is a little off. We've also seen adaptive headlights for the high and low beam lights to adjust automatically depending on the detections of light from upcoming vehicle. One of the few cons about those systems is that depending on reflection of the pavement or sometimes signs put along the highway or rural road, is that the system will shut itself down because it perceives a car in the upcoming direction while it was only the reflection from an upcoming signs along the highway. One of the other system that is really interesting is the blind spot information systems. We've seen with the process of aging that there might be some neck and range of motion limitation for people when they're driving, and the blind spot information system is providing someone's information when someone is in your blind spot. So you might be driving and looking forward. You look at your side mirrors once in a while, but then the side mirrors, or sometimes it's a heads-up display in the dashboard, will inform you if someone's standing in your blind spot information, in your blind spot zone of your car. We've also seen the implementation with some of those systems that if someone would put their turn signal on and they would start a lane change maneuver, the car would prevent them to do that lane change maneuver if it detects that there's someone standing in the blind spot for the vehicle. So there's not only blind spot information system, but there's also lane change maneuver mitigation that are embedded in some of those vehicles to prevent side swipes, collision on the run. Forward collision, there's two separate families in there, and I'm presenting them all together today, but they're presented differently and separately in the website because they're clearly different in terms of presentation and what they'll do for the driver. The first one, the forward collision warning, is considered as a passive device. So if you get too close from someone in the car and the system detects that you're gonna have a frontal collision with the car in front of you, the car will beep, system alarm might shake the steering wheel or even your seat, but the car is not going to do anything more than just shouting you alarms of various forms. Whereas for the forward collision mitigation, the car will take on itself to either prime the brake, sometimes reduce your speed or brake completely or partially, so that it reduces the forward collision impact. And this is where there's a lot of confusion for consumers, because depending on the tests that were done, and we've seen it with the IHS, and we also see it in terms of results coming from IHS reports, is that there's a lot of confusion with mitigation, because most people think that because they have a forward collision mitigation systems in their car, they mostly all think that the car is going to break itself before I end up having a forward collision. However, it has been shown that some of those systems might reduce the speed by 30, 40, 50, even sometimes by 70 kilometers per hour, but it might not prevent all types of forward collision, and we have to be aware of that. Another important piece here is the lane departure system, and as similarly to the forward collision systems, there's either a passive system, which is the warning, and there's also the mitigation that could be implemented for the system. So your car could be warning or beeping when you're drifting from your lane without having activated the turn signals, but it could also mitigate the fact that you're drifting from left to right by keeping your car back in the middle of the road. These are they're mostly presented as lane keeping assistance system, and these are, when combined with forward collision warning and the automated cruise control, they're not considered that combination as a level 2 of automation. So someone could drive on the highway, having their car centered in the lane and having the speed adjusted automatically to the car in front of them. So these are types of combination that we're slowly starting to see by car manufacturers. So this is a broad and general presentation of the technologies that are presented out there, but I just want to take a step back and presenting why, and the explanation why such a presentations of technologies to be available for every Canadian is important. These are results from Nandavar that were conducted back in Australia, is that we can clearly see that when driving and purchasing a car, there's a part of education that can be done by the car dealership, but people also have to be aware of what are those technologies doing and what can I do and what I know about them. There's also those systems that influence the purchase of those systems. I've addressed it earlier, but we also see that more than often people do have the technologies in their car, but that's not part of the decision they'll take when purchasing that new cars. There's also the questions that was brought by Nandavar, is that how do people learn about the advanced driving assistance systems in their car? And unfortunately, their response was by trials and errors on how it works and how it doesn't work. It's rarely former documentation. They won't read the booklet that stands in their glove box. And this is really concerning, because if people learn by trials and error, like driving on the highway to see when is my system's not going to work, they might take risks that they should not be taking. And that's a really high safety issue for all road users. Hopefully, people did mention, though, that there is clearly a place for proper information, and their perception on learning and training could be with the use of engaging and effective material to show and how we can control all that parts of road safety. More importantly, and we have to keep that in mind, is that all those levels of automation will bring some ironies of the automation when we're driving. One of the issues is that task assignment, like how will people understand who's responsible for driving at any point of time, depending on the level of automation that I'm using. There's also the section of cognitive load, like, am I going to be more and fully distracted when I know I'm using some levels of technologies or some of those technologies, because I'm assuming that the technologies will prevent me of having a collision. As part of that task assignment, there's also the control that comes with the car, and we can see it as kilometer driven versus kilometer ridden. The portion here is that I might have a car that has really high level of automation, but while I'm doing that, I'm not only losing my ability and my experience as a driver, is that I might be traveling a lot, but actually I'm never quite driving my cars. There's my level of confidence behind those technologies and those automation that I have to keep in mind, because they're really going to be the biggest piece of challenge that we're going to face. Will people adopt or not those technologies? And if they adopt them with a really high level of confidence, will they be too confident for using those technologies despite the limitations of those systems? And more importantly, as drivers, and we often see it with graduated driving license access with our younger drivers, or we even see it at the end of the age spectrum when people start to decline the number of kilometers they drive per year. We also see sometimes a loss of skills of driving, is that with the use of that automation, there might be the appearance of de-skilling of driving capacity, and we have to be aware of that. As part of the website and what are the technologies to come, there's going to be sections in regards of driver monitoring systems. We see mostly some of them in a really high-end vehicle right now. They're often presented in the dashboard as a cup of coffee to remind people that they might be distracted or they might be drowsy while driving. There's also going to be a section on pedestrian detection, cross-traffic alert. So the cross-traffic alert is more similar to the forward collision warning, but for traffics that are perpendicular to the driver. And the last one is the intelligent speed adaptation. So this is these are systems that are mapped with known GPS information and X and Y position of the vehicle, where the car knows where the person is driving, and that it would adapt or warn the driver if they're exceeding speed limit by telling them and reminding them what is the speed limit in a particular area. It could also adapt for automatic cruise control, as an example, as long as there's networks or the quality of the maps and they've been updated recently enough. I cannot stress enough the importance of the winter impact for us in Canada as Canadian. Most of these studies have all been conducted mostly in countries of the South, quote unquote, mostly in the US, a place where it never snows. So what are going to be the impacts on those technologies of inclement weather, winter, snow, hail, and these types of things, and these should be considered for future studies. And as I've said, there's also going to be another sections on technologies adoption and behavioral adaptation, because as I've shown you in that graph that showed results and studies done up to 2017, is that we'll also have to look not only at how those technologies are doing in terms of road safety, but also at how people are using them overall to prevent the happening of a collision. So overall, we've seen that we went from that rightmost side of my presentation with the collision black stars towards, yes, the advanced driving safety systems, but we'll also have to cover up and to consider in that continuum the questions of advanced driving safety systems, but also the driver's action at the last minute, but also the prevention and education that we do provide with that green circle, sorry. The overall presentation of schemes of road safety and how we can educate and better show people what are their responsibilities and empowerment in regards of road safety. Once again, I want to acknowledge the funding received by Ministère des Transports et de la Mobilité Durable who make that project possible that I have the pleasure to show you today. Système avancé de sécurité des véhicules, which is like just an example of what I've showed you earlier, but now with the French version of the website. I'll now be pleased to take questions that were asked in the Q&A box, and you'll also be provided in the chat segment, and by the email we're going to send you out the link to get access to all the information that I've just shown you today during that webinar. Thank you.